What if a supervolcano erupted tomorrow? Noms asterisk. The day the Earth opened tomorrow morning begins like any other day. People wake up. Traffic fills the streets. Aircraft cross the sky. Farmers walk into their fields. Millions of people check the weather without realizing that something far beneath the ground has already begun to change. Deep below one of Earth's largest volcanic systems, magma is rising. Pressure has been building for centuries. Rock surrounding the underground reservoir begins to crack. Superheated water flashes into steam. Gases trapped inside the magma expand. And beneath the surface, the planet is preparing to release an unimaginable amount of energy. At first, the warning signs appear small. A series of earthquakes shakes the region before sunrise. Most are weak. Windows rattle. Animals become restless. Pictures fall from walls. People living nearby open their phones and see reports of dozens of tremors. Then, hundreds. Scientists monitoring the volcano notice that the ground is swelling. Satellite measurements reveal that sections of the landscape have risen several centimeters within hours. Gas sensors detect increasing amounts of sulfur dioxide and carbon dioxide escaping through cracks. Hot springs begin changing temperature. Some disappear. Others boil violently. Roads split. Steam rises from places where the ground had been cold the day before. Volcanologists immediately understand that the system is unstable, but they do not know whether a major eruption will occur in minutes, days, or not at all. Volcanoes rarely provide simple warnings. Some show dramatic activity and then become quiet. Others erupt after only brief signals. Governments issue evacuation orders for communities close to the volcanic zone. Highways fill with vehicles. Families leave homes carrying documents, food, clothes, and whatever they can fit inside their cars. Emergency shelters open in nearby cities. Military units begin moving people away from the most dangerous areas. Airports cancel flights. But the evacuation zone is enormous. Millions may live within reach of ash, earthquakes, fires, or fast-moving volcanic flows. There is not enough time to move everyone. By midday, the earthquakes grow stronger. Each tremor opens new fractures underground. The ground moves as if something massive is pushing upward from below. Buildings sway. Power lines fall. Water pipes break. Landslides block mountain roads. The sky remains clear. For a few hours, the disaster is still invisible. Then the center of the volcanic region begins to collapse. The first explosion sends a dark column of ash into the atmosphere. It rises several kilometers in minutes. Lightning flashes inside the cloud as ash particles collide and build electrical charges. The sound travels across the landscape like continuous thunder. People hundreds of kilometers away see a black shape growing above the horizon. Many begin filming. They do not yet understand that they are watching the beginning of one of the largest natural disasters in human history. The first eruption is only a warning. Pressure continues building beneath the volcano. Magma rises through fractures. Gases expand violently. Then the main chamber fails. The ground tears open. A vast section of the landscape explodes upward. Rock that has existed for millions of years is shattered into dust. A column of ash, gas, and volcanic debris rises dozens of kilometers into the sky. It punches through the lower atmosphere and reaches the stratosphere. Daylight disappears beneath the cloud. The eruption does not resemble a single mountain producing lava. A supervolcano may erupt across a huge area. Multiple vents open. The ground collapses into the emptied magma chamber below, forming or enlarging an enormous caldera. Forests, roads, rivers, and entire sections of land fall downward. The earthquake produced by the collapse is felt across the continent. But the most immediate danger is moving outward from the eruption zone. Pyroclastic flows race across the landscape. They are mixtures of superheated gas, ash, and rock fragments. They can move faster than vehicles on a highway. They do not behave like ordinary smoke. They are dense, violent avalanches of heat. Anything in their path is overwhelmed. Forests ignite. Buildings disappear. Rivers boil. The flows move through valleys and over ridges, destroying communities that had not evacuated in time. There is no realistic way to outrun a large pyroclastic flow once it is close. Sheltering inside a house would not be enough. Even reinforced structures could be buried beneath meters of hot ash. Within the central zone, survival would depend almost entirely on having left before the main eruption began. Farther away, the danger arrives more slowly. Ash begins falling from the sky. At first, it resembles gray snow. Small particles settle onto cars, roofs, fields, and roads. People step outside and hold out their hands. The ash feels soft. But volcanic ash is not like material from a fireplace. It consists of sharp fragments of rock, minerals, and volcanic glass. It can irritate the eyes, damage the lungs, contaminate water, destroy engines, and accumulate with enormous weight. The daylight becomes orange, then gray, then almost completely black. Streetlights switch on in the middle of the day. Cars slow because drivers can barely see beyond their windshields. Ash enters air filters and damages engines. Roads become slippery. Electrical systems begin failing as wet ash coats power lines and equipment. Aircraft are grounded across a vast region. Volcanic ash can melt inside jet engines, coating internal components and causing them to fail. Planes already in the air are redirected. Some airports hundreds or even thousands of kilometers away close as the ash cloud spreads. Global flight routes begin changing within hours. The modern world suddenly discovers that the sky itself is no longer safe. By evening, communities hundreds of kilometers from the volcano may be buried beneath several centimeters of ash. Roofs begin collapsing. Dry ash is already heavy. When rain mixes with it, the weight increases dramatically. People climb onto rooftops with shovels, trying to clear the material before buildings fail. Hospitals distribute masks. Emergency broadcasts advise residents to remain indoors. But fine particles enter through doors, windows, ventilation systems, and cracks. People with asthma and other respiratory conditions begin arriving at emergency rooms. Drinking water becomes contaminated. Ash enters reservoirs, wells, rivers, and treatment facilities. Pumps become damaged. Filters clog. Livestock struggle to breathe. Crops are covered. Grass disappears beneath gray dust. Animals cannot find clean food or water. The landscape begins losing its color. Rain falling through the eruption cloud mixes with ash, producing thick mud. This mud flows downhill through river valleys. Known as lahars, these volcanic mudflows can move with enormous force. They carry trees, vehicles, buildings, and boulders. Communities far from the main eruption may be destroyed hours later when a river suddenly becomes a moving wall of concrete like debris. Bridges collapse. Roads disappear. Rescue routes are cut off. The eruption continues through the night. The sky above the volcano glows red as magma reaches the surface. Lightning repeatedly flashes through the ash cloud. The sound of explosions is constant. Satellites detect the plumes spreading across the atmosphere. Weather systems begin carrying ash away from the region. Countries that were never threatened by the direct eruption prepare for falling particles and flight disruptions. But scientists are watching something even more dangerous than ash. Sulfur dioxide is entering the stratosphere. There, it begins reacting with water vapor to create tiny sulfate aerosols. These particles can remain high above Earth for months or years. They reflect a portion of sunlight back into space. A large eruption can temporarily cool the planet. A supereruption could affect temperatures around the world. The immediate disaster may destroy an entire region, but the material entering the atmosphere could threaten civilization far beyond the volcano. 12 hours after the eruption begins, communication from the surrounding area becomes limited. Cell towers have failed. Power grids are damaged. Roads are blocked by ash and collapsed structures. Rescue aircraft cannot fly safely. Emergency teams move slowly through darkness created by the volcanic cloud. People trapped in isolated towns wait for help that may not arrive. Some shelter inside schools, underground parking areas, basements, and public buildings. They seal windows with cloth and tape. They ration clean water. They listen to radios for updates. Outside, ash continues falling. By the end of the first day, the eruption zone is almost unrecognizable. The central landscape has been erased. Entire forests are gone. Rivers have changed direction. Cities are buried. A vast caldera now occupies the ground, where mountains, lakes, and roads once existed. Millions of people across the continent are without electricity, transportation, or reliable water. Global markets begin falling. Food and fuel prices rise. Air travel across major routes has stopped. Governments declare emergencies. But the eruption has not finished. And even when the volcano finally becomes quiet, the disaster will continue in the atmosphere. Tomorrow began as an ordinary day. 24 hours later, part of the world has disappeared beneath ash. And above the planet, a veil is beginning to form between Earth and the Sun. The years without summer. 1 week after the supervolcano erupts, the explosions finally begin to weaken. The ash column becomes smaller. Earthquakes continue beneath the caldera, but the most violent phase appears to be ending. From a distance, the eruption may seem over. It is not. The immediate destruction has created a humanitarian crisis on a continental scale. Millions of survivors need shelter. Homes have collapsed beneath ash. Roads are buried. Water systems are contaminated. Hospitals are operating beyond capacity. Entire communities must be relocated. But beyond the disaster zone, another transformation is beginning. The atmosphere is changing. High above the clouds, sulfate aerosols spread around the planet. Stratospheric winds carry them across oceans and continents. Unlike heavy ash, which usually falls relatively quickly, these tiny particles can remain suspended for a long time. They reflect sunlight. The sky begins appearing unusually pale. Sunsets become deep red and purple. At first, the visual effects seem beautiful. Photographers capture glowing horizons. People in countries far from the volcano watch spectacular sunsets, without seeing any ash on the ground. But weather stations begin recording a decline in temperature. The cooling is not equal everywhere. Some regions change more than others. Ocean currents, winds, seasons, and geography all influence the effects. But across the world, average temperatures begin falling. Summer days become colder. Frost arrives earlier. Snow remains longer in mountain regions. Rainfall patterns shift. Farmers notice that crops are growing more slowly. Plants receive less sunlight. The first harvest after the eruption is smaller than expected. In some areas, it fails completely. A supervolcano would not automatically freeze the entire planet. Earth would not enter an instant permanent ice age, but even a temporary global cooling of a few degrees could severely disrupt agriculture. Modern food systems depend on predictable seasons. Corn, wheat, rice, soybeans, and other major crops require specific temperature ranges. They also depend on rainfall arriving at the right time. A colder growing season could reduce harvests across multiple continents simultaneously. This is what makes the event so dangerous. A normal drought may affect one region while another produces enough food to help. A volcanic climate shock could damage many of the world's major farming areas at the same time. Within months, grain prices rise sharply. Countries begin limiting exports. Governments protect domestic supplies. Nations that depend heavily on imported food face shortages. Supermarkets still contain products, but prices increase each week. Poorer families begin skipping meals. Humanitarian organizations struggle because the countries that normally donate food are also facing reduced harvests. The global food system begins turning inward. The eruption has not only damaged farms, it has damaged transportation. Air travel remains disrupted in regions affected by ash. Railways and highways near the volcano are unusable. Factories producing fertilizers, machinery, and food processing equipment may have been destroyed. Ports become crowded as more goods move by sea. Insurance costs rise. Fuel becomes more expensive. Every stage of food production becomes harder. Farmers attempt to adapt. They plant crops that mature more quickly. They shift planting seasons. They use greenhouses. Governments build indoor farms under artificial lighting. Countries release grain from emergency reserves. Scientists develop new varieties designed for colder temperatures and reduced sunlight. But these solutions require time, money, electricity, and political stability. Not every country has access to them. After 1 year, the world experiences what future historians may call the first volcanic winter. Snow falls in places where it is rare. Mountain glaciers begin expanding. Northern growing seasons become shorter. Tropical regions may not freeze, but changing rainfall can still destroy crops. Some areas experience drought. Others face continuous rain and flooding. The global climate system does not simply become colder, it becomes less predictable. Ocean ecosystems also respond. Reduced sunlight affects microscopic algae near the surface. These organisms form the base of many marine food chains. If their growth declines, fish populations may change. Fisheries already stressed by pollution and over-harvesting could collapse in some regions. Communities that depend on the sea for food lose another source of survival. On land, animals struggle with changing seasons. Migratory birds arrive at the wrong time. Insects emerge when flowers are not blooming. Herbivores find less vegetation. Predators follow their prey into new regions. Some species adapt, others decline. The volcanic winter becomes an ecological crisis as well as a human one. Could humanity survive? Yes. A super eruption would be catastrophic, but it would not necessarily end the human species. The outcome would depend on the eruption's size, location, atmospheric conditions, and how governments responded. Humanity has advantages that ancient civilizations did not possess. We can predict weather, store food, move supplies across continents, grow crops indoors, produce synthetic nutrients, preserve seeds, and communicate globally. But these systems depend on cooperation. The greatest danger might not be the volcano itself, it could be the political reaction. As food becomes scarce, countries may close borders. Migration increases from regions where farming has failed. Millions move toward warmer climates and better food supplies. Receiving nations may resist. Military forces protect grain warehouses, reservoirs, ports, and farmland. Conflicts begin over fertilizer, fuel, seeds, and clean water. Governments accused of hiding food supplies face unrest. Cities experience protests. Some states collapse. Others become more authoritarian. Emergency laws remain in place for years. The world begins dividing between regions able to maintain advanced infrastructure and those losing it. Wealthier nations construct enormous climate-controlled farms. Underground facilities grow vegetables beneath artificial light. Warehouses store grain for many years. Nuclear, hydroelectric, geothermal, and renewable energy systems power protected food production. Meat becomes rare and expensive because feeding animals requires large amounts of grain. Diets shift toward potatoes, beans, algae, mushrooms, insects, and laboratory-produced proteins. Food is designed for survival rather than pleasure. Cities establish ration systems. Every person receives a limited amount based on age and medical need. Restaurants close or become luxury spaces for the wealthy. Food waste becomes a serious crime. Households grow crops in basements, tunnels, rooftops, and abandoned buildings. Printed guides teach people how to preserve food, collect rainwater, and identify edible plants. Knowledge once associated with farming communities becomes essential everywhere. In the regions buried by ash, rebuilding is even harder. Volcanic ash can eventually enrich soil because it contains minerals. Some volcanic regions become highly fertile over long periods. But immediately after a super eruption, thick ash can make land unusable. The material may be meters deep. Rivers remain clogged. Rain repeatedly turns ash into mud flows. Wind lifts particles into the air for years. People entering the abandoned zone require protective masks and specialized vehicles. Some cities are never rebuilt. They remain buried as modern versions of ancient Pompeii. Future archaeologists might dig through hardened ash and uncover cars stopped on highways, offices frozen in time, and homes abandoned during the evacuation. The disaster zone becomes a permanent monument to the eruption. Elsewhere, humanity begins redesigning civilization around the possibility of another event. Countries create larger food reserves. Seed banks expand. Emergency warehouses are built underground. Power grids become more decentralized. Governments construct shelters capable of filtering ash from air and water. Airports install improved volcanic monitoring systems. Satellites continuously measure ground movement, gas emissions, and temperature changes at large volcanic systems. Education changes. Children learn how to protect themselves from ash. Families keep masks, water, food, and radios in emergency kits. Volcanic risk becomes as familiar as fire or storm warnings. After several years, the sulfate aerosols gradually leave the atmosphere. Particles combine, become heavier, and fall. The sky begins clearing. More sunlight reaches the ground. Average temperatures slowly rise toward their previous levels. The volcanic winter weakens. But recovery does not happen instantly. Food systems have been transformed, governments have fallen, borders have changed, millions of people have migrated. Some regions are still covered in ash. The world that existed before the eruption does not fully return. The survivors have learned that civilization can be disrupted, not by war or technology, but by the geology beneath their feet. The volcanic system itself may remain active. Steam continues escaping from cracks. New hot springs form. Lakes fill sections of the caldera. Small eruptions occur for decades. Scientists monitor every tremor, afraid that another major event could follow. Over centuries, plants begin returning to the devastated zone. Moss grows across ash. Grass follows. Then shrubs. Forests slowly cover areas once burned and buried. Rivers cut new channels through volcanic deposits. Animals return. The landscape remains scarred, but life rebuilds. Eventually, the caldera may become a lake. Visitors arrive to see one of the most dramatic places on Earth. They stand on observation platforms above a peaceful landscape. It may be difficult to imagine that the same ground once changed the climate of the entire planet. That is the unsettling nature of supervolcanoes. They do not always look dangerous. Some are hidden beneath lakes, forests, plateaus, and tourist destinations. There may be no perfect cone, no constant stream of lava, no obvious mountain warning us to stay away. The danger is buried below. A vast volcanic system can remain quiet for tens of thousands of years. Human civilizations rise and fall during the silence. Cities are built. Roads cross the landscape. People begin believing the volcano belongs to the distant past. But underground, heat remains. Magma moves. Pressure changes. The planet continues its slow geological activity, regardless of human history. Fortunately, supereruptions are extremely rare. Most volcanic eruptions are far smaller. Scientists monitor dangerous systems using earthquakes, gas measurements, satellites, and changes in the ground. A large volcanic system would likely show warning signs before a major eruption, although the exact timing could remain uncertain. There is no reason to assume a supervolcano will erupt tomorrow. But the possibility reminds us how thin the foundation of civilization truly is. Beneath every city is a moving planet. Continents drift, faults break, magma rises, mountains grow and collapse. We build our homes on Earth's surface and think of the ground as permanent. But the ground is only the outer skin of an active world. So imagine waking tomorrow to a low vibration beneath the floor. The windows begin shaking. Birds rise suddenly into the sky. A dark column appears beyond the horizon. The sunlight fades. Ash begins falling like snow. And then a message arrives. This is not a drill. The volcano has erupted. The question is no longer whether you can escape the explosion. The question is whether civilization can survive the years that follow.